Hey guys, this video here is for you if you were gone a day or two and you want to get caught up on this parallel line conversation that we've been having for the last few days. This video is going to show you what we've been doing in class so that you can do this. So this one is, we're going to take a picture from Google and we're going to put it into Geogebra and we're going to put some lines on it and measure what we need to get our transversal on there, measure some angles, and make an argument of whether the lines are parallel or not. So I'm going to go to Google here and I'm going to search for parallel lines. Okay, I like real world pictures. Let's see here. Let's check some of these logs. That's kind of an interesting picture there. So I'm going to click on this. I'm going to right click or hold down on your picture, save image, and save it somewhere. I'm going to just put it on my desktop. Okay, so now just open up Geogebra and then make your window so that it's not full screen so you can move it. And my picture is right here on my desktop, so I'm just going to open my Geogebra so that I can see my picture file. If yours is in like your documents, you're going to click on the little library icon here and you're going to make this window come up and go find your picture. But once you have your picture in your window, then all you have to do is just drag it on. The computer's running a little slow. So, oops, not the reflection one. That was for a different talk. Okay. Oops. Here we go. There's my picture. Okay, so now we got our picture in here. Remember these little points down here? If we move those around, it'll move our picture size and whatnot. So we got a bunch of logs here. I'm going to pick a couple that look like they're parallel to me, meaning, you know, if you were to extend the log, so let's put a line on top to talk about like extending a log here. So maybe I'm just going to pick one. This one seems kind of good, right here and here. So there's a log, and I think it's going to be parallel to maybe this log right here. So there's my two lines that I want to check out to see if they're parallel or not. If your picture, if you wanted it to be a little more faint, kind of see-through, you can hold down on your picture, go to Object Properties, hit the Color tab, and you can change its opacity, oops, which will make it a little bit more faint, and then now it's not so bad. So let's check to see if these are parallel. So mathematically, our argument, we have to introduce a third line, our transversal. So I'm going to just make a line that's going to intersect these two. So I'll just use these 2 points. So there's our transversal. So if these two lines are parallel to each other, that means that their behavior is the same. So that means like if we just keep going on forever and ever and ever, then they're behaving the same way, which means that distance between them is always going to stay the same. And as I'm zooming, or just kind of scrolling here, I'm seeing that gap get further and further and further. So I would imagine these aren't parallel. But let's use angles. That's how we check to see if they are behaving the same. We have this one line that's consistent between both of these lines. So the way that we describe behavior of lines are angles. So let's measure an angle pair. You need to know your angle pairs. Make sure you have some notes on that. So we can choose whatever we want. Maybe I want to measure an alternate interior angle pair. So I'm going to do this angle here and this angle here because I know that when lines are parallel, those two angles are going to be equal to each other, right? And that's how we make our argument. So now I'm going to measure this angle up here, I need to have a point on this side of the angle, since this is my angle here, right? And I don't have one, so I'm going to grab my point tool and just put a point on there. And then I need a point on this side, and I have one here. I can use this point. So I have my 3 points for my angle, so I'm just going to go in a clockwise direction. Remember, vertex is always the second point. Okay, I'm going to measure this angle down here, so I need a point on this side of the angle. So now I can just measure this. Okay, I'm looking at mine. One of my angles is 82.26, another one's 85.09. In your picture, you may have parallel lines, but they're off just by a little bit. We can actually change the rounding. If you go to options, you can go to the rounding here, and we can round to, say, the first decimal place, which would be like our tenths. So now it's just a little bit better. And if you want to try to make the lines parallel, it might be easier to do now that we have it rounded to the tenth here. So my lines weren't parallel because those angles weren't the same, right? So that would just be my argument. So if this is my argument, sorry, I was trying to make that parallel, but that's not really what we need to do. Then I'm going to grab my text box here. I'm going to click somewhere on my screen, and I'm going to write my argument here. The logs aren't parallel because the alternate interior angles are not congruent. Done. There's our proof. There's our reasoning for why these aren't parallel. So again, if you wanted to try to make a parallel, you would just make that angle. Try to be exact. So you can make them the same, and then they're going to be parallel. Okay? So that's how we do that in GeoGebra.